కనిపిస్తున్నప్పుడు
పాయింటర్ కనిపిస్తుంది. Sir, I will start at 11 o'clock. So I will introduce. So later you can start the lecture, sir.
ఎంతమంది వచ్చారు చూడండి, అంటే
జాయిన్ అవుతుంది.
11
మీకు కూడా
5కి
కనిపిస్తుంది, మీకు కూడా కనిపిస్తుంది చూడండి, పార్టిసిపెంట్స్ అని క్లిక్ చేయండి.
71 అన్నారు.
అవునవును సార్, జాయిన్ అవుతూ ఉంటారు.
ఓకే.
సరే మీరు ఓకే. Good morning to all of you. This is the 28th webinar of IGS Guntur chapter. This webinar is organized by IGS student chapter, Chalapati Institute of Engineering and Technology, LAM, Guntur. IGS Guntur chapter established in 2003, organized a number of seminars, workshops, significant being IGC 2009 National Conference. I am thankful to Engineer D.B. Bhavana Rao, former Chief Engineer, Roads and Buildings Department, Andhra Pradesh, accepted to deliver webinar lecture on construction and quality assurance in flexible pavement. Before introducing the speaker, few announcements to participants. I request all the participants, please stop your video. Now, during the lecture, you are going to chat with the host only. During the lecture, you can chat audio and video issues only. Please do not share your information and questions during the lecture. After completion of the lecture, I will share Google Form link to share the content of the lecture and your feedback. Question answer session through chat at the end of the lecture. Our next webinar tomorrow at 11 a.m. So that is on 18th Thursday by Mr. Ravi Sundaram, Director, Sengrass Geotechnica Private Limited, Noida. And title of the webinar lecture is Geotechnical Investigations in Difficult Ground Conditions, Field Experiences. Now I feel it privilege to introduce speaker of today, Engineer D.B. Bhavana Rao. He is BE Civil Engineering, MTech Soil Mechanics and Foundation Engineering, and PG Diploma in Alternate Dispute Resolution, Fellow of Institution of Engineers and Life Member of Indian Geotechnical Society. Worked in different cadres from Assistant Executive Engineer to Chief Engineer in R&B Department for 33 years and retired as Chief Engineer R&B in July 2010. Worked as a consultant for 7.5 years for EGIS India Consulting Engineers Private Limited. During this tenure, worked for 7 years as a team leader, project manager of third-party quality audit team in the World Bank assisted national cyclone mitigation project in the 9 coastal districts of Andhra Pradesh. This project includes construction of roads, bridges, buildings. Also worked as advisor for roads and buildings for 1 year in Amaravati Development Corporation, Vijayawada, for Government of Andhra Pradesh. As a EE R&B quality control, he studied the reasons of premature damage of several roads and found that using red earth in GSB and WBM in roads is the main cause for early damage of roads. His article on adverse effects of using natural gravel in subways, bays, waterbound MACDUM was published in the monthly IRC magazine Indian Highways in the month of February 2005. Educated the department engineers by conducting several workshops and ensured stopping the use of red earth in GSB and WBM in roadworks. It improved the performance of roads, saved huge amounts to government exchequer. Another article on steps to improve roads on black cotton soils was published in September 2007 issue, New Buildings, Materials and Construction World, NBM and CW. From the year 2000, giving presentations on how to construct durable roads, buildings, bridges to field engineers. Organized several one-day workshops throughout Andhra Pradesh for all the department field engineers to bring quality awareness among practicing engineers. Prepared a handbook for highway engineers, which is useful for all field engineers. He is regularly giving expert lectures to field engineers of R&B, Panchayat Raj, Public Health, Singareni College, AP Housing, AP CRDA, Amaravati Development Corporation, and other departments. Helped in resolving the launchpad problem at ISRO Sriharikota in 2009. Now I request Engineer D.V. Bhavanarao to start his lecture.
Thank you, Ramarao garu. Let us start this presentation. Today's presentation is on construction and quality control in roads, flexible pavements. There are some important codes I am showing. This IRC 37 2019, it is design of flexible pavements. It is coming with a software designed by called IIT Pave, developed by IIT for design of flexible pavements. Also, this IRC SP 72 is for flexible pavement design for rural roads. IRC SP 89, this is for soil stabilization, soil and stabilization with cement, lime, fly ash, and chemicals, etc. for the stabilization of subbase and base, etc. Next, IRC 59, guidelines for use of geosynthetics in road pavements and associated works. As per this code, we can use geosynthetics also in the pavement, construction pavement. All the design guidelines with case studies and examples are given in this code. Similarly, for evaluation of the existing pavements, IRC 115, this is using falling weight deflectometer technique, and IRC 81, guidelines for strengthening flexible road pavements using Beckelman deflection method. These are the codes related to my presentation. This presentation is based on these codes and both specifications, and also photos, etc., taken during my tenure as consultant and chief R&B engineer, and also at Amaravati Development Corporation. This is both standard specifications. This book is called Orange Book because IRC has given this color, orange color, to only this publication. In this, most of the specifications related to roads and bridges are available. And in India, in the execution of roads and bridges, we have to follow this standard specifications. And you find most of the specific agreement clauses are as per this Orange Book only. For rural roads, more the specifications are also there, but now we are dealing with more specifications for roads and bridges. In this Orange Book, there are a number of sections are there. Each section is called section 100, 200, 300, like that. For example, I have shown some sections also. This section 300 is for earthwork, erosion and drainage. Separate clauses numbers are given for each item. For example, 305 is for embankment construction, including subgrade and shoulders. Suppose we are executing a work having some method for embankment or construction. It shall be done as per class 305 of most specifications. It is specified in the agreement document. Then we have to go to this class 305 and we have to study, understand each and everything in that class. In each and every class, what is important is that in every class, the physical requirements required for the materials to be used, the construction methodology, and the quality control operations during execution, the acceptance criteria, and the rate for that item. All these items are included available in each class of this orange book. That's why in any agreement, we have to read the description of all the items and note the clause numbers specified in the agreement. Then we have to go to this orange book and understand each specification. If we do like that, we will be having we will be able to get the work done in a systematic manner and up to the good quality standards. That's why it is very important. Now in section 400, subbases and bases, etc. there. In this 401 granular subbase, we are mostly using for flexible pavements and rigid pavements. 403 cement treated soil and cement fly ash treated soil for subbase and base. We are I am showing one case study of this also. And also we are using wet mix mechanism for subbase. We are using wet mix mechanism for base in most of the cases. And regarding this section 500, which deals with bituminous layers, 502 is prime coat, 503 is tack coat, 504 is bituminous mechanism. The most important items are dense bituminous mechanism 505 and 507 bituminous concrete. We are extensively using these two items. And new items are also there. Microsurfacing and stone matrix asphalt. I'm showing these items also during this presentation. Some other important specifications from this orange book are section 100 general light clearance, concrete pavements, etc. And most important is section 900 quality control for roadworks. For all the quality control operations, we have to refer this section for all the roads and bridges works. Now coming to the pavement structure, what are the technical names associated with the pavement? This is not to scale. For easy understanding, I have prepared this sketch. In this, top is bituminous surfacing. Below that is base. Base means it is a WBM or WMM. Subbase is for granular subbase, etc., or for subbase. BT and bituminous surfacing, base course and subbase course are called. It is called road crust. This road crust is resting on the subgrade. If you use good materials, this angle increases further, reduces further, and reducing the stresses on the layers. That's why we prefer granular material for base and granular for subbase to reduce the stresses on subgrade. This design is based on this pavement crust composition shall be designed based on the strength of subgrade and the traffic intensity. Design traffic like supposed to be on the pavement structure. For subgrade strength, we have to find out effective subgrade CBR, which means that we have to first find out CBR of subgrade material, and below that subgrade 500 embankment layer also, we have to find out the CBR value. Based on the CBR of this embankment, top 500 embankment layer and the subgrade layer, effective CBR can be found out. And also we can find out the traffic intensity and conduct the traffic surveys and finalize the traffic intensity for the design life. This design life traffic is expressed in million standards axis. Depending on the design traffic and the effective CBR of subgrade, we can find out what is the requirement of GSP, what is the requirement of the base course, what is the thickness and composition of bituminous layers. This design is available in IRC 37, and also one software is also there, is given along with that IRC 37. Using the software also, we can design the road crust. Some examples are also given in the IRC 37. Some ready-made charts are also available. For easily following it, we need not design it. We can use those tables also for finding the thicknesses of GSB, wet mix macadam, or DBM, VC, etc. for each roads. In the IRC 37, in the flexible pavement, the maximum stresses, tensile stresses, strain near the surface, we can some tensile stresses develop at the top of the BT surface, and tensile stresses developed at the bottom of the BT surface. These two are BT surfaces. A top layer is rut restraint layer and bottom layer is fatigue restraint layer. Generally, we provide DBM in the bottom layer and bituminous concrete, etc. in the top layer. We have to find out stresses developed here and stresses, tensile stresses, strains developed here. And also on the subgrade, vertical strain on subgrade is also important. If the vertical strain on subgrade increases over the permissible limits, rutting, etc. is likely to take place. That's why at the time of design, we have to find out strains at the bottom of top of the bituminous layer and the bottom of the bituminous layer, and vertical strain at the top of the subgrade. This can be obtained from the software also. By giving the inputs, we can find out these values also. And we have to check whether those values are within allowable limits for the design traffic we are doing it. Like this, here GSB is provided here and wet mix macadam is provided for base course, DBM for binder course, and bituminous concrete for wearing course. We can also, nowadays, they are going for cement treated subbase, cement treated base also to reduce the use of aggregates. By adopting these things, we can reduce the thicknesses of the layers. That's why we can save some materials also. Also, they are having good confinement because you are using cement. The aggregates are confined due to the use of cement. We can reduce the quantity of aggregates to be used. If CTB and CTSB are used, we have to provide granular crack relief layer over that before laying bituminous course. Bituminous layer, we can lay 100 mm thick wet mix macadam or are like this stress absorbing membrane interlayer. We can either provide 100 mm wet mixed macadam as the crack relief layer or about 10 mm thick stress absorbing membrane interlayer. By using either WVMM 100 mm or this semi, we are this reflective cracks can be arrested in the bituminous layer. That's why when we are go for cement treated base or cement treated surface, we have to use either crack relief layer or stress absorbing membrane. What is stress absorbing membrane? It is applying 10 to 12 kgs of elastomeric modified bitumen per 10 square meters and covered with 0.1 cubic meters of 11.2 mm chips. The thickness is about 10 mm. And we need not consider that thickness for design reason. Also, one more option is this is a recycled asphalt pavement. RAP means recycled asphalt pavement. It is mixed with some virgin aggregates to satisfy the required gradation, and bitumen or emulsion or formed bitumen is used to supplement the bitumen requirements. Suppose in the RAP, we are getting about 3.3% of bitumen. Then if the actual requirement is 4.5%, we have to add 1.5% bitumen in the shape of emulsion or foam bitumen. And we have to add some aggregates to satisfy the requirements either for the DBM or bituminous concrete. This also is being executed in national highways because we cannot increase the level, finishing level of the road all the time. Because all the drains, everything, etc. are fixed with the road top level. We cannot increase the road level by adding for new materials. By doing this recycling, we can save aggregates, we can save bitumen also. That's why this is also done. Here, CTSB is done yes, for subways and RAP with emulsion or bitumen, foam bitumen stabilized RAP with this aggregates is provided as, it is also provided instead of DBM. Here are base course and binder course. It acts as base course and binder course also. And this is another option where here it is CTSB as subbase and WMMS granular base and bituminous layers as usual. Now coming to this embankment portion, embankment and subgrade, etc. We have to conduct several quality control tests to select the materials to be used. The important quality control tests, why they have stipulated these tests. We have to understand the idea behind selecting these tests, stipulating these to us. There are other tests also. I am showing the most important tests in this presentation. We are conducting liquid limit test. It indicates approximately the water absorbing nature of the material. Plasticity index is liquid limit minus plastic limit. It indicates the softening nature of this material. If the PI is more, the soil is likely to get softened very quickly. That is the why we don't require material having higher plasticity index values. Also, if the water absorption is more, that is also not good for road construction. Water absorbing is required for agriculture purpose, but more water absorbing nature is not required for road construction. Similarly, free swell index is another test which gives the expansive nature of the soils. That's why if the soils are expansive, those soils are also not good for road construction. That's why they have stipulated limits for liquid limit, density index, and free swell index. In roads, for most of the items in the embankment, subgrade, and shoulders, the liquid limit specified is maximum 50%. Density index maximum limit is 25%, and free swell index maximum limit is 50%. That is the reason why they have put the limits on these three important values. Similarly, we find for any materials to be compacted, we have to find out maximum dry density and optimum moisture content. These we can find out these values for any material in standard Proctor's compaction or modified Proctor's compaction. We use modified Proctor's for compaction for all the high volume roads. We have to use standard Proctor's compaction in the low volume roads. Similarly, in buildings, etc., we find severe bearing capacity for the design of finalization of the foundation. Here, we find we go for California bearing ratio. It is equivalent to severe bearing capacity for buildings or bridges. These tests are most important tests for road construction, particularly embankment, etc. Now these are the limits for, these are values required for embankment, these are values required for subgrade. The liquid limit, density index, free swell index values are same for both embankment and subgrade and shoulders. But MDD requirements are slightly different. If the embankment is up to 3 meters height, the minimum MDD is 1.52. If it is more than 3 meters height, MDD required is 1.6. For subgrade and shoulders, it is 1.75 minimum. Similarly, effective CBR. Effective CBR means CBR of the subgrade and CBR of the 500 mm top layer of embankment. It shall be minimum 5% if the traffic is more than 450 commercial vehicles per day. In the era of construction, we have to find out the traffic intensity in the era of construction. If it is more than 450 commercial vehicles per day, we have to adopt a minimum CBR of 5%, minimum effective CBR. Then during compaction, what is important? The relative compaction. Relative compaction means field dry density versus laboratory maximum dry density. It is called relative compaction. For subgrade and shoulders, it shall not be less than 97% at the time of compaction. For embankment, it is 95% minimum. That's why we have to remember this 95% and 97% for embankment and subgrade and shoulders. Expansive clays are not permissible below the 500 mm, just below the subgrade. We should not allow expansive clays in the 500 mm layer just below the subgrade. After that 500 mm, we can allow expansive clays also. Then when we are compacting expansive soils, the relative compaction required is 90 to 95% because it is not possible to compact expansive soils up to 97% or 98%. It is impossible. Up to getting 90% is also very difficult, particularly in BC soils like this. Now this Proctor's compaction test. We are having two types of compaction tests. Standard Proctor's compaction Every test is done as per IS codes. Here all the soil tests are as per IS 2720. This SPT is part 7 and modified product compassion is part 8. The difference between is this thing. These two tests is we use light hammer and height of drop is 310 mm, and also we compact the specimen in 3 layers. For modified process test, heavy hammer 4.89 kg is used and a drop off hammer is 450 mm. We compact the specimen in 5 layers. That's why we get more higher values in modified process compaction and compared with standard process compaction. Here, for a particular soil, this moisture content versus relative dry density is like this. We are gradually increasing the water content. As the water content increases, the dry density is increasing up to a certain point. After that, if you increase further water, the dry density gets reduced. That's why this point is called maximum dry density, and the corresponding water content is called optimum moisture content. It is the same for this modified process compaction also, but the value is higher. MDD is higher and OMC is lesser. That's why what it indicates that for achieving a good compaction, we have to maintain water content near to the optimum moisture content at the time of rolling. That is the most important thing. If we increase the water content, the density is gets reduced. If we reduce the water content also, the density will reduce. That's why we can find out the optimum moisture content and maximum dry density in this test. During construction, we have to do systematically in layers. That is very important. The maximum layer thickness is 250 mm, compacted thickness is 250 mm. We are having vibratory rollers. We can do layers of up to 250 mm compacted. But if you are not having vibratory rollers, the maximum layer thickness, compacted thickness is 200 mm. This 250 mm or 200 mm, the loose thickness depends on the type of the material. Suppose we are compacting some red soil like gravelly soil, about we require a minimum thickness about 300 mm thick for getting 250 mm compacted. We have the loose thickness is varying depending on the type of soils. We have to maintain the water content at the time of rolling at a range of +1 to -2 of OMC. Suppose OMC is 15%. We have to maintain the water content in the range of 13 to 16 because we cannot maintain exactly 15% everywhere. There some range is given. Before rolling, we have to break clods larger than 75 mm for getting uniform compaction. If stones are there, the soil surrounding that stone cannot get compacted. That's why we have to remove or break the stones if they are more than 75 mm. Also, the width required shall be at the bottom for each layer shall be 0.6 meters extra on both sides to ensure proper compaction. This is during construction. I am showing one example. Here, the source is approved by conducting all the tests, and the contractor is making arrangements to transport the earth to the site. In the site, they give marking and mark a specified area like about 1000 square meters or so. Suppose this is the marked area, and let us assume that it is having 1000 square meters. If it is having 1003 square meters and we want to spread 300 mm thick loose soil, for 300 mm, we are assuming that this 300 mm loose thick is giving 250 mm compacted. The maximum loose thickness, compacted thickness is 250 mm. We can also go for 200 mm or less also, no problem. It shall not be more. Here we want 300 mm loose quantity material to be dumped on this place. Because the area marked is 3000 square meters and the loose thickness is 300 mm, which means that we require 300 cubic meters of earth. In that particular area, suppose one tripper is getting 6 cubic meters in each trip, we require about 50 trips to get 300 cubic meters. Like that, we have to calculate and instruct the concern to dump such this material. We are asking here to dump 50 lorries in this 1000 square meters area. After dumping, we are grading this material to have uniform layer. After grading, we have to find out the moisture content present here, because some moisture content is present in this soil. In our case, if the optimum moisture content is 15%, suppose we are having 6% moisture here, we have to supplement it with 9% for moisture content to achieve the OMC. Because we know that we are getting 300 cubic meters of earth, we have to add 9% moisture. Then we have to make it 15%. Like I'm telling one example, but it is to be calculated like that. After watering this one, we shall not allow water to be stagnant more at some places. It shall be uniformly sprinkled. If the water is more than plastic limit value, that spots will become plastic and not good for compaction. If in a particular place water content is more than liquid limit, that area soil is likely to be converted into liquid state. That soil is useless and now we have to remove that soil. That's why we have to sprinkle moisture water uniformly. And after that, we do the compaction. After compaction is over, we have to find out field dry density by conducting sand replacement method or this core cutting method. We can adopt anything and find out, calculate the maximum field dry density. And we will compare this field dry density with laboratory MDD. If it is more than 95%, it is okay for embankment. If it is more than 97%, it is okay for subgrade. Embankment and subgrade, the procedure is the same, or even subbase also. Regarding compaction, we have to follow the same principles. In some areas, we come across with some very narrow bunds, which is not actually, it is not compacted properly, and it is not advisable to widen the formation by adding soil on both sides. It is always better to dismantle this bund and the loose soil. Bund is to be dismantled, lumps broken, spread to the required bottom width, plus 2 into 0.6 meters, section 2 longitudinal and cross profile, adding water to reach OMC, and compaction to achieve required into compaction. Maximum compacted thickness of a layer is 250 mm. Like that, depending on the quantity available and the width required, we have to compact it one or two layers with the existing dismantled material. It is explained here. Here, these two layers are executed with the dismantled bund. These soils may be expensive also. That's why we have fixed relative to compaction as 90 to 95%. After this, we are bringing borrow soil and forming layers. And in the embankment portion, the minimum required RC is 95%. And we are forming subgrade 97% in the top two layers. Like this, we have to form this, and we can do layer GSP, etc. on top of it. By doing this methodology, we are using the bund material, but in which compaction is also not done properly long back. We have to construct the road as shown here systematically. Three layers are embankment layers. These two layers are subgrade, and also requirements are also shown here. This is GSP for full width to act as a drainage layer. We are not providing GSP for full width because of the cost criteria, but GSP shall be provided for full width from edge to edge. This is base course, this is BT course. This extra width of 0.6 meters on either side, we can use this material again after making the slope. Contractor can reuse this material. Now coming to GSB, in both fifth revision, GSB gradations were changed. Earlier we are having gradations in the fourth revision, slightly different. In the fifth revision, what they give grading 1, 2, 3, 4, 5, 6. In this, grading 3 and grading 4 gives more permeability because for the drainage layer, minimum permeability required is 300 meters per day. Whatever GSP we are adapting, when it is to be provided for drainage layer, minimum permeability requirement is 300 meters per day. We have to check for permeability also. That's why grading 3 and 4 are recommended for drainage layer. Grading 1, 2, 5 and 6 are recommended for filtration layer, filter layer or separation layer because they are dense, having number of sizes. They are very dense and prevent ingress of soil from the bottom or top. That's why for filtration or separation layer, 1, 2, 5, 6 are recommended, and for drainage layer, grading 3 and 4 are recommended. For GSP, what is the physical requirements? Aggregate impact value shall be less than 40%. Liquid limit and plasticity index on materials passing 425 micron shall not be more than 25% and 6% respectively. CBR, minimum 30% CBR is required. If water absorption is present greater than 2%, we have to conduct wet aggregate impact value. Wet aggregate impact test means the aggregate shall be soaked in water for 24 hours and we have to do the aggregate impact test. That is the wet aggregate impact test we will get. If water, this as per IRC 37 2018, minimum thickness of drainage layer as well as filter layer shall be 100 mm. Minimum thickness of each layer for drainage or filtration, we have to maintain a minimum thickness of 100 mm. If 200 mm GSV or more thickness GSV is provided, we can adapt to two layers, one layer for drainage layer and one layer for filtration layer. But in some cases, we can the GSV requirement thickness is less than 200 mm. In that case, we have to provide a minimum 150 mm thick. You this this sketch. This is subgrade. This is pavement layers. The first layer is filter layer. The bottom layer is filter layer or separation layer. Filter layer is provided over subgrade, which means that it prevents the ingress of the subgrade materials into the GSP layer. That's why on top of subgrade, we are providing this filter layer or separation layer. That which means that grading 1, 2, 5, and 6. On top of this separation layer, we are providing drainage layer. This drainage layer means grading 3 or 4. What they are providing up to the edge of the pavement. At the edge of pavement, at the time, in the ending 0.5 meter shall be stabilized with emulsion or cement, because otherwise the aggregates are likely to go away, move away from the pavement, fall away from this pavement. To prevent that, we have to confine these layers with 2% cement or 2.5% emulsion. Also, they have provided below shoulder also, they have provided filtration layer, which means that the soil shall not be ingress into the filter layer and to the drainage layer. In any case, the drainage layer shall not be allowed any ingress of soil. That's why this is the arrangement made. This is GSP grading 4. Grading 4 means you see this number of voids present here. It is because we require a 300 meters per day permeability. This grading 4 or 3 are very useful. But we have to, it appears a bit loose. That's why ends shall be stabilized. This IRC 37 has given the guidelines for which is to be adopted drainage layer for grading 3 and 4 and 1, 2, 5, 6 for filter or separation layer. If the design thickness of granular surface is less than 200 mm, we cannot provide two separate layers of 100 mm. Then in such a case, both drainage and filter layers cannot be provided separately. A single drainage cum filter layer with the GSV gradation 5 to 6, 1, 2, 5, 6 can be provided. Either 5 or 6 can be provided as per most specifications. When single layer GSV is provided, it is preferable to go for 5 or 6 gradations for the GSP. Nowadays, they are adapting this cement treated subbase and base. Major works because the emphasis is on reducing the use of aggregates. That's why You also see the some loose nature of this GSB also. Considering these things, they are now adopting cement-treated subbase and cement-treated base also. What are the requirements for CTSB and CTB? Gradation of aggregates for CTSB is grading 4 of Mott's table 400-1. That is the grading I have shown previously. This grading is to be adapted for CTSB. Grading for aggregates for CT cement-treated base is given in Moth table 400-4, which I will be showing you next in the next slide. What is the requirements of CTSB? Strength requirements. Minimum UCS unconfined strength required is 1.75 MPa at 7 days and 3 MPa at 28 days. Design resilient modulus 600 MPa. Resilient modulus. It is also resilient modulus. In the design they are finding resilient modules for all the layers, including bituminous layers, sub-base layers, etc. This CTSB resilient modulus shall be 600 MPa. Minimum thickness recommended is 200 mm. It is if CTSB is provided, the minimum thickness recommended is 200 mm. Similarly, for CTB, minimum UCS required is 4.5 at 7 days and 7 MPa at 28 days. Design resilient modulus or CTB is equal to 5000 MPa. We have to design in such a way that how much cement we have to use for CTSB and the minimum cement requirement is 2%. And for the cement treated base, you have to use more cement. We shall get these UCS values and resilient modulus values. So in such, we have to design in such a way. And also this modulus of rupture or flexural strength is 20% of this 28-day UCS. That is 20% of this 7-day strength. And this 28-day strength is 1.4 MPa. We have to consider these things in the design of CTSB or cement treated base. Actually, we have done CTSB in Amravati Development Corporation. And by doing CTSB, we got a reduction in the thickness of wet mix macadam and DBM also, DBM. This is the table 400-4. This for cement treated base, we can use this gradation. It is given in both orange book. The minimum cement content is 2%. CTSB 7-day minimum UCS is 1.75. Lab UCS value shall be more than or equal to 1.5 times field values. For getting if we want 1.75, we have to get about 1.5 times of 1.75 in the laboratory at the time of design. Requirements of liquid limit and plasticity index are also given for the CTSB materials. Now here, the design cement content is 2.1%. Here it is a pug mill. The cement is mixed with the graded materials. Spreading is being done. Here only 2.1% of cement is added. Now you observe the difference between this and our regular GSB. Now the field density tests are conducted. We have to achieve 98% of relative compactation for GSB. GSB or subgrade or wet mix mechanism or basis also we required relative compactation is 98%. They are conducting this test. Here at the time of watering, CTSB looks like this. For 7 days we have to water it. And some specimens are cast for testing unconfined compressive strength test. Here the specimen is like this. Here the required VCS is 1.75 MP. Here we are getting more than 5 MP. Also this water sensitivity test is also done after immersing the specimens for 24 days and testing again. The strength is about, the value is about 95%, 94%. The specimens you observe. The summary of the test results. Now, IRC is recommending to use this stabilizers, different type of stabilizers also, by giving accreditation to some chemicals, etc. What is the aim of these things? To reduce the use of the aggregates. We are getting depleted because most of the quarries are getting exhausted. Now we are finding it very difficult to find sand. And in AP, getting sand is very difficult also. And very costly, very difficult also. Similarly, we may, for one day, it may become very difficult to find out the aggregates also. In some states, we are not having aggregates also. They have to convey these aggregates from a very long distant quarries. To reduce the use of these aggregates, we are going for CTSB and CT base, cemetery base, and also the IRC is recommending to use some chemical stabilizers also, provided they satisfy all the requirements. Here, I had the experience of using this chemical stabilization. That's why I'm showing this one. What are the guidelines given in IRC SP 89? Minimum UCS for subbase is 1.75 MPa at 7 days and 3 MPa at 28 days. If we want to use it in subbase, we have to get these values. Similarly, minimum UCS requirement for base is 4.5 MPa at 7 days and 7 MPa at 28 days. Durability of the stabilizer-based material to be tested by wetting and drying for 12 cycles. The maximum permissible weight loss after the procedure is 14%, and the residual strength of the specimen after the test shall not be less than 20% of the 28 days UCS strength. The commercial chemical stabilizer has to be tested for toxicity and leaching also. And if it is all these things are satisfied, we can use that stabilizer. That is the conditions given in this IRC SP 89. In several words, number of stabilizers are used, particularly for PMGS savers in the Panchayat Raj department, etc. I find this one additive is giving a good results. That's why I'm showing this one. The conventional design of pavement is like this. A compacted soil subbase, granular subbase, subgrade and subbase, wet mix macadam, DBM, BC, and like this. Now, here two cases are there. One is for CT with cement treated subbase and cement treated base. And another is this using this chemical additive. You observe this up to for traffic less than 20 MSA. Here, BC thickness is 50 mm. Cement treated base is 170. Cement treated subbase 200. This is compacted soil zone. Here, for traffic industry more than 20 MSA. It is one example, not a particular this one. CTSB is 200, CTBase is 140, DBM, BC is DBM and BC are put together 100 mm. Now using this chemical, this is the bottled compacted subgrade. And this is the stabilized layer. The stabilizer layer includes the existing metal, existing soil, or by existing bitumen, layers also, and cement and this additive. This is for 300 mm. If the thickness, if the traffic index is up to 20 MSA, and if it is 350 mm, if the traffic index is more than 20 MSA. After this, they are providing GCRL or SAMI. GCRL means granulated crack relief layer. SAMI means stress absorbing members interlayer. We have to provide either GCRL or SAMI on top of this layer. The thickness is about 10 mm and we can provide BC. Similarly, here also, here DBM and BC are also provided. By comparing with this one, we are getting a lot of reduction using new aggregates. We are using mostly existing aggregates. If no aggregates are there in the existing road, we have to add some new aggregates. We have to design this one depending on the strength requirements and on the traffic intensity and the CBR values of the subgrade, etc. And we have to satisfy those requirements. Like that, suppose if an existing road is there with some metal, etc. We are not using any new materials. We are using only the existing metal and existing soil, and we are adding cement and stabilizer, and we can do the compaction. And we find out the CBR values, etc. by conducting UCS values, by taking course, and ensure that the required UCS values. And we will go for a GCRL or SAMI and do the bitumen surfacing required. This is the procedure given. Cement additive will be thoroughly recycled using a Ridgen cold recycler machine up to a depth of 300 mm or 350 mm as per design, while adding controlled amount of water through water tanker to achieve the OMC. The surface will then be compacted by, they are doing three types of compaction. First, they are compacting with 20 MT pad foot ham vibratory roller. And after this compaction, they are grading the surface and compacting with a tandem vibratory roller. Finally, they are using compaction by PTR. Three types of compaction is done for that 300 mm or 350 mm thick layer. On top of this, they have to take course and test for UCS and other tests also. After getting clearance, they have applied prime coat. After 24 hours, stack coat is applied. Then stress absorbing membrane or GCRL is provided. Depending on the design, DBM or BC are provided over it. One example here, they are spreading first cement. Now they are spreading this additive. Now they are recycling it. If the road is having some BT layer also, we need not remove it. With that also, we have to recycle it. If the no metal is available in a particular area, particular road, because it is a existing road is a earthen road, then we have to add some aggregates also to get the required strength. Here in this road, some aggregates are available. Now they are doing this gradation. After the rolling with this pad foot roller, they are using this gradation. After the compaction is complete, they are curing. So for 7 days, it is to be cured because cement and additive are there. Curing is required for 7 days. After the testing and satisfying all the requirements, they are allowing bituminous layer, bituminous wearing coat here. They have done one road in near Vijayawada. This is called Salpeta Poranke Road near Vijayawada. They have adopted this technology and have done a road. Yes, for some stretch, it is double lane road. It is after laying blacktop in. It is prior to the taking of this work. They have done some roads in Krishnapatnam port also. Using this technology, some works are being done in Kerala and Punjab states also. And they are doing several works in Panchayati Raj department in Andhra Pradesh. Now, Hyderabad airport also, the runway is being renovated using this technology. These are the course taken after 2 years by Central Road Research Institute. They are doing some roads in Krishna district. Now coming to wet mix macadam. These are the gradations, gradation. Now there are 6 types of emulsion. Generally for prime coat, we use slow setting SS1 and for rapid setting RS2, RS1 for tag coat. For macro surfacing, etc., we will use modified emulsions. We have to control the temperatures of bitumen, aggregates, mixed temperature, laying temperature, rolling temperature. Suppose when we are adopting VG30, these are the temperatures requirements, and temperature of bitumen and aggregate shall not be more than, difference shall not be more than 14 degrees. It is very important. And we have to complete the rolling before the mix reaches 90 degrees. This is prime coat. Prime coat can be done with emulsion SS1 or cutback bitumen. We are not using cutback bitumen because of the polluting nature. This is the prime coat. This is wet mix macadam also. The prime coat penetrates and binds the top layers. This is the application of prime coat. You see the picture. Code shall be applied when the WMM layer is in a very dense compacted stage. We shall not disturb the wet mix mechanism. We have to clean the dust and apply this prime coat. We have to do watering, just slight watering before the application of this prime coat previous day. And we have to clean the dust. We should not disturb the denseness of the WMM before the application of the prime coat. For checking the rate of spread, we can place a tray and find out whether we are using sufficient required quantity of prime coat. After the bitumen is coming out of this emulsion, it appears like this. Similarly, we do the tag coat. These are the tests for bituminous aggregates, grain size analysis. Flakiness elongation shall not be more than 35%. Aggregate impact value, maximum 30% for BM, 27% for DBM, 20 and BDM and SDBC, and 24% for BC. If we adopt stone matrix asphalt, it shall be less than 18%. Also, durability test and water absorption test, stripping value, minimum 95%. Retained tensile strength, it shall be minimum 80%. Polished stone value is required for wearing coats, minimum 55% value. This is gradation for BM. Bitumen content is 3.3% for 80 to 100 mm layer, and for 50 to 75 mm layer, 3.4% bitumen. Now this mixed design of DBM and BC, DBM and BC are controlled mixes. We have to design for Marshall stability value, flow value, voids in mineral aggregates, and voids filled by bitumen, and air voids, net air voids in the mix. For these 5 items, we have to design the bituminous mix for DBM or BC. These are the Marshall stabilities, Marshall samples, 102 mm by 63.5 mm diameter. This is the Marshall's equipment. Here one load measuring gauge. This is the specimen. Here it is the deformation measuring gauge. We get flow value in this case. We get the compressive strength or so, similar Marshall stability value in this. We slowly apply the load and find out the maximum load. It is called maximum stability, Marshall stability value. This is the equipment. This is a compaction, specimen compaction. No, actually this mixed design is to be done for different bituminous contents. Keeping in mind this design bituminous design mix, this agreement specified bitumen content or minimum specified bitumen content. After this test, we get 5 charts. Bitumen versus stability, bitumen versus flow value. Flow value means the workability. Bitumen versus unit weight. Bitumen versus air voids. Bitumen versus voids filled by bitumen. We get these 5 values depending on, we considering all the 5 charts, and we have to find out the bitumen at which all the 5 values are satisfying the requirement. That bitumen content we have to adopt during execution. Also, in the IRC 37/2018, it gave some guidelines for the DBM because they wanted to avoid moisture-induced distresses and for better bottom-up fatigue resistance. Bitumen-rich DBM is proposed. Actually, we have to use more bitumen for the DBM bottom layer to that is more bitumen than specified in the both specifications. In two-layer DBM, DBM1 is bottom layer, and the DBM grading 1 is bottom layer to be adapted for bottom layer, and DBM2 is to be adapted for top layer. If we are going for single layer DBM, target air voids is 3.5% for mixed design. Generally, mixed air voids is permitted is 3 to 5%. He is asking us to go for 3.5% air voids at the time of design if single layer DBM is adopted, and increasing the volume of bitumen content. We have to increase the volume of bitumen content then specified in the Morse gradation. Compaction to be achieve to have 4.5% or less air voids in the field. After at the time of design, the air void shall be 3.5%, and after the compaction, the air void shall be 4.5% for the single layer DBM. If you are going for two layers of DBM, for the bottom DBM layer of two-layer DBM, target air voids is 3% for mixed design. Compaction to achieve 4% or less air voids in the field. This is we have to change the design of DBM during execution, and it may lead to some variation in the bitumen content also. But to reduce this fatigue cracking, bottom-up cracking, which is common in the bottom layers of DBM on high traffic roads, this IRC 37 has recommended this thing. But in every case, generally what we do is for DBM and VC, we design to have 4% air voids for mixed design because the requirements of air voids is 3 to 5%. We will design for 4% air voids. So that slight variation also in the air voids also, it will be in the range of 3 to 5%. And compaction is to be done to have air voids up to 8% or less. Actually, we wanted the airless to be 8% at the time of execution for that bituminous concrete or the top DBM layers, top actually. But here they have changed it to 3.5 and 4.5 and 3 and 4% for the DBM layers. For the bituminous concrete, we can adopt this one. This is the two gradations for DBM. This grading one is for DBM bottom layer. This grading two is for top bituminous DBM. This is voids in mineral aggregates. From this table, we can find out what is the voids in the mineral aggregates. Also, we come across several in more specifications that what is nominal maximum aggregate size. Nominal maximum aggregate size is the one sieve larger than the first sieve to retain more than 10% material. It is one sieve larger than the first sieve to retain more than 10% of material. Maximum aggregate size. One sieve larger than nominal maximum aggregate size. Here they have given nominal maximum particle size. In this table, you see here 26.5 is the nominal maximum size. it is retaining more than, first sieve retaining more than 10% of material. In is 7.5 is the maximum aggregate size. From this table, we can find out the voids in mineral aggregates for a dBm. And the design mix, design requirements of dBm and BC, you find the maximum minimum stability value 9. It is similar to compressive strength. Minimum flow value, maximum flow value 2 to 4. It indicates the workability of the bituminous mix. Compaction level 75 blows on each side of the specimen. Percent air voids 3 to 5%. Marshall coefficient also 2 to 5%. Percent voids in mineral aggregates, the earlier table we have shown. Percent voids filled with bitumen 65 to 75, which means that the air voids present in the mix, voids present in the mineral aggregate, that volume 65 to 75% we have to fill with bitumen. The balance remaining portion is called air voids. It is 3 to 5%. These are the job mix formula at the time of design. I have shown some example of this gradation. This chart shows the outer lines of the gradation and the inner line for this gradation of this. For one dBm sample, I am showing this one on 37.5 mm sieve. 100% is to be passed and 100% is passed. The very allowable variation on this sieve is 8 plus or minus 8%. But we should not change 100%. That side is 100%.
Excuse me, sir, there is a break in audio.
Okay. హలో
సార్
వినిపిస్తుందండి?
హలో
వినిపిస్తుంది అంటారా? వినిపిస్తుందా?
ఆడియో అనేబుల్ టు హియర్ సార్.
సరే ఓకే అండి. మామూలుగా కంప్యూటర్ తీసి మైక్లో మాట్లాడుతాను.
Sir, Bhavan Rod sir, your audio is unable to hear.
హలో వినిపిస్తుందంటారా?
Sir, Bhavan Rod sir, we are unable to hear your voice.
హలో Hello? Hello?
Hello. Hello, Bhavan Rao garu. You are unable to hear, sir.
Hello?
Hello.
Hello? అదే నేను ట్రై చేస్తున్నాను.
Sir, reconnect చేయండి. మళ్ళీ స్టాప్ షేర్ అండ్ స్క్రీన్. ఓకే ఓకే. Hello, are you able to hear my voice? Hello, please wait. So, and the speaker is reconnecting once again. Sorry for the inconvenience. Now, Bhavan Rao garu, వినిపిస్తుందా నేను మాట్లాడేది భవన్ రావు గారు? హలో, ఒక్క నిమిషం. భవన్ రావు గారు
వినిపిస్తుంది.
వినిపిస్తుంది ఇప్పుడు.
ఓకే.
ఒక్క నిమిషం. ఇప్పుడు మళ్ళీ స్క్రీన్ షేర్ చేయండి సార్.
స్క్రీన్ షేరింగ్ ఇస్ పాస్డ్ అని వస్తుంది.
నేను మళ్ళీ ఒక్కసారి చూస్తాను. మీరు ఒక్క నిమిషం. హోస్ట్ కూడా చేశాను. డబల్ క్లిక్ చేయండి. ఇక్కడ మీకు ఎంటర్ ఫుల్ స్క్రీన్ అంటుంది.
యువర్ స్క్రీన్ పాస్డ్ అని వస్తుంది.
మళ్ళీ స్టాప్ చేసి మళ్ళీ స్టార్ట్ చేయండి. పవన్ గారు వస్తుందండి. ఇక్కడ రాలేదు, ఇక్కడ ఆగిపోయింది స్క్రీన్ షేరింగ్.
రెజ్యూమ్ షేర్ అని ఉంది.
సరే, ఎండింగ్కి వచ్చిందా?
ఇంకా 10 minutes ఉంటుందండి.
స్టాప్ షేర్ చేసి మళ్ళీ స్టార్ట్ చేయండి షేర్.
లేకపోతే మొత్తం మళ్ళీ జాయిన్ అవ్వమంటారా? లేకపోతే
అట్లా కాదు, మీకు స్క్రీన్ షేర్ అవ్వట్లేదు. లేకపోతే నా స్క్రీన్ షేర్ చేసి మీ పీడిఎఫ్ ఉంది నా దగ్గర,
అదే చేయండి.
ఒకసారి మీరు స్టాప్ చేయండి స్క్రీన్.
స్టాప్ షేర్ మీరు చేస్తారని మాట్లాడతాను.
అదే నేను ఒకసారి ట్రై చేస్తాను. అది మీకు
పీడిఎఫ్ ఓపెన్ చేసి మీరు షేర్ చేయండి.
స్క్రీన్ షేర్ అయింది, కనిపిస్తుందండి?
కనిపిస్తుంది.
కానీ ఇప్పుడు ఇక్కడ 117 స్లైడ్ లో ఉన్నాను. ఇక్కడ నేను అక్కడ
బ్యాక్ వెళ్ళండి.
ఫార్వర్డా?
బ్యాక్.
హలో,
వెనక్కి వెళ్ళండి.
మీరు ఎక్కడ స్టాప్ చేయమంటే చెప్పండి, అక్కడ స్టాప్ చేస్తాను.
కొద్దిగా ఇంకా వెనక్కి పోండి.
హలో,
రైట్, ఇంకా వెనక్కి.
స్లైడ్ నెంబర్ చెప్పండి.
అదే నెంబర్
వినిపిస్తుందా నేను మాట్లాడేది?
దగ్గరికి వచ్చింది.
భావన గారు, నేను మాట్లాడేది వినిపిస్తుందా?
ఓకే, దీన్నే స్లైడ్ షో పెట్టండి.
హలో భావన గారు, నేను మాట్లాడేది మీకు వినిపించట్లా?
వినిపిస్తుంది. నాది వినిపించడం లేదా? నా మాట వినిపిస్తుందా? రామారావు గారు, నా మాట వినిపిస్తుందా? వాయిస్ వినిపించడం లేదండి. ఇప్పుడు చూడండి. రామారావు గారు, ఇప్పుడు వినిపిస్తుందా?
హలో భావనరావు గారు,
వినిపిస్తుందా?
ఇప్పుడు వినిపిస్తుందండి. ఇప్పుడు ఇది 111 స్లైడ్ లో ఉంది, అక్కడ ఉంచమంటారా?
కొద్దిగా ముందుకెళ్ళండి.
ముందుకు వెళ్ళండి.
సరిపోదు.
అదే కొద్దిగా ఫాస్ట్ గా ఫినిష్ చేయండి.
స్లైడ్ షో పెట్టండి.
స్లైడ్ షో దీంట్లో ఇది పీడిఎఫ్ కదా?
F11 కొడితే ఫుల్ వస్తుంది.
ఓకే,
ఫంక్షన్ F11, కంట్రోల్ F11.
అవట్లేదు. నాకు ఫంక్షన్ F11 కొట్టినా రావట్లేదు.
వ్యూలోకి వెళ్ళండి. వ్యూలోకి వెళ్తే వ్యూ పైన వ్యూ ఉంది
view.
కదా, అందులో ఫుల్ స్క్రీన్ ఉంటుంది చూడండి.
ఓకే, కనిపిస్తుందండి ఇప్పుడు?
ఓకే.
ఓకే సార్, కంటిన్యూ చేయండి.
These are the gradations for stone matrix asphalt. Two gradations are there.
ఇదేంటి ఈ
One
స్క్రీన్
is for 40 to 50 mm and another is 40 to 75 mm. This is the most effective. This is very popular specifications. In India also, they are using this also. It can be used both as DBM and BC also. One gradation can be adapted as instead of DBM. One gradation can be adapted as BC. Next downward turn side. Gradation for filler material. Next in. Here, what is the difference between these, the BC, etc. is the bitumen content is 5.8%. Celluloid fibers 0.3% by weight of total mix. That fibers are added. This is the difference between the DBM and VCA and SMA. And also aggregate sizes are more also here. This bitumen voids in mineral aggregate is 17%. And asphalt drain down. For all the bituminous mixes, this drain down problem is there. To arrest this drain down condition, celluloid fibers are added and also bitumen content is more. Next. This is a micro surfacing. It is been if the road is having less but not much distress, instead of renewing it with BC or so, we can go for micro surfacing. It is being done for National Highway between Vijayawada and Hyderabad. I am showing some photos also. I will show. Next. There are two gradations. One gradation is for 4 to 6 mm and another gradation is for 6 to 8 mm. These two gradations are there. Depending on the thickness, we can select the gradation. Next. This is bitumen content also here. Mix dry residual binder 6.5 to 10.5 and 5.5 to 10.5. Next. This micro surfacing is done between National Highway 65, between Vijayawada and Hyderabad. Some photos I am showing. Okay, next. One by one, Zubet. This is the machine used for this micro surfacing. This is the micro surfacing. In National Highway, they have done this only for the rutting portion with only. They adopted 8 mm thick in the rutting portion. For full width also we can adopt, but if the full width is done, we have to redo the painting, etc. again. Here already some ruts are formed, and in that wheel rutting portion, they have done for that width only this micro surface. It can be done this on roads like Outer Ring Road and National Highways, etc. when there is not much distress in the road. That's why we need not raise the BT surface by considerable margin by using this material. This is done with emulsion, not bitumen. Next. Next. After every BT renewals, we have to conduct this roughness index using this roughometer or some new materials or new machineries also available. The limits for roughness index for the roads, different layers are given in this table. Okay. Next. This is the extra widths required. Minimum radius of horizontal curves. Next. Next in recommended vertical gradients. Next. This is based on the traffic intensity for widening. Now all the quality control requirements are given in the coming slides. I need not show it because the presentation is available. You can see them. You can get the presentation because this Ramarao is uploading this presentation in the website and he is giving the link. Now with this I can close the presentation. Any doubts are there, I will clarify this.
Sir, are you able to hear, sir? Bhavan Rao garu?
నాకు మీకు
Okay. Vinistunది, sir. So now I will before question answer session, I will share Google Form link, and its purpose is to sharing the content in PDF format and your feedback. I request you all the participants copy this. So sorry, intermediate the audio problem and the screen sharing problem. So now I will share the Google Form link.
ఎన్ని చార్ట్స్ ఉన్నాయండి అన్న? రామారావు ఏమైనా చార్ట్స్ ఉన్నాయా?
ఇంకేమి chat చేశారు సార్?
ఎవరైనా ఉంటే మైక్ ఆన్ చేసి మాట్లాడమనండి.
సో చాట్స్ ఇంకా పంపించలేదు సార్, ఇప్పుడే నౌ వీఆర్ సెండింగ్ ది గూగుల్ ఫామ్ లింక్. ఆఫ్టర్ దట్ దే ఆర్ గోయింగ్ టు షేర్ ది చాట్.
లేదంటే ఎవరైనా అన్మ్యూట్ చేసి మాట్లాడినా పర్లేదు అని చెప్పి.
So the presentation will be shared to the email IDs. So those who we received the feedback, and I have shared the Google Form link. So now once again I am sharing. I request you, all of you, copy this Google Form link, and now I request you, so you can send your questions through chat. Now I request Engineer Bhavan Rao to look after the chat questions, or I will read the question and we can make an answer also. That is also left to you.
మీరు చదవండి.
Atla. So I will read. So now I request participants send your questions through chat. So are you able to hear, sir?
వినిపిస్తున్నాను.
So one of the persons they have sent unable to hear. So I think it may be the problem with his.
ఒకవేళ ఏమైనా చాట్ పంపలేకపోతే మాట్లాడటం వీలైతే మాట్లాడతాం.
So please send your questions through chat.
మా ఫోన్ నెంబర్ కూడా ప్రెజెంటేషన్ లో ఉంది. ఒకవేళ ఎవరైనా ఇక్కడ లేకపోతే తర్వాత నాకు మెసేజ్లు పెట్టిన వాటి రిప్లైస్.
Okay, you can send the
వాట్సాప్ కూడా అదే నెంబర్.
Okay. So any questions? Any questions?
Questions ఏం లేవంటారా?
Will be. So are they able to hear or not? So one of the persons unable to hear. And now I have got one question, sir, from Ujwal Solanki. Bituminous compaction, there is a GMM is suggested and contractor need to compact 92% of GMM. But this is still not in the practice. All are following Marshall density and consider 90 by 98%. Please suggest your view.
Actually, first during bituminous mixing, preparation of mix for spreading, we have to find out theoretical maximum specific gravity. That theoretical specific gravity means it is 100% zero voids density. As per the specifications, we have to compact the layer up to 92% of the theoretical maximum compaction, which means that after completion of compaction, the voids are likely to be in the range of 8%, about 8%. So that after 2 or 3 years due to the secondary compaction, the net air voids is likely to fall in the range of 3 to 5%. In such a case, the road is durable for a very long time. That is the main idea of this thing. But some people are insisting that 98% is to be done on Marshall stability density. It is not specified in the standard specifications. We have to follow theoretical maximum specific gravity and minimum 92% compaction at the time of compaction. Up to 95% is also okay. Beyond 95%, it is not advisable because the voids content is getting reduced. But for the DBM, the conditions are different because on many DBM layers, some cracking, etc. are observed during construction also. That's why they wanted to increase the bitumen content and reduce the voids. That's why for the if 2 layers DBM is proposed, bottom layer is to be designed for 3% air voids at the time of execution and 3.5% voids at the time of compaction. If that is the against the normal norms for bituminous construction. That 92% won't apply for this bottom layer DBM. On the bottom DBM layer, we have to achieve around 96.5% on theoretical maximum specific gravity. But bituminous concrete, etc., we have to follow come back to 92% of theoretical maximum specific gravity. That is the condition.
Sir, there is another question from Mr. Ashok Kumar, where rainfall is lesser. In such a case, for GSB construction, mixing open grading and close grading is the right option to get maximum density.
Now the close grading and open graded, actually grading 1, 2, 5 and 6 are close graded GSBs. And grading 3 and 4 are open graded GSBs. If we SC 37 guidelines specifies that if we are going for a single layer GSB, you go for grading 5 or 6. If two layers of GSB is proposed, that is more than 200 mm thick or more, bottom layer shall be either grading 1, 2 or 5 or 6 and top layer shall be 3 to 4. Now they have not given any separate things separately for low rainfall area and high rainfall area in both specifications. But in both specifications, there is some difference in the gradations. But as far as both specifications, we need not, there is not much difference between the low rainfall area and high rainfall area.
Question, sir, to improve the strength of the sub-base and the base course, we are having various stabilization techniques, but any new technology available?
in most of the works now, they are adopting a cement treatment for subbase and base. For a subbase, we are adding about minimum 2% cement. And for base, around 3% or so. But I have shown one chemical during execution in this presentation. That additive is it has become popular now. Now there are other chemicals also, but the results are not very very good. This appears to be very good. That's why I have shown it. But stabilization must be done with those machinery. Perfect machinery shall be there, because they have. This is a German technology I have shown, in which all the machinery they have imported from Germany. That's why they are not getting good results. And they are doing also this airport runway work at Hyderabad airport using this technology. I think right now that is the best chemical that is used for stabilization of this roads, subbase or base. They are stabilizing top 300 mm layer for medium traffic roads and about 350 mm for the high volume roads. The name of the stabilizer is stable roads. It is called stable roads. It also feels like a cement.
Yes, sir. Thank you, sir. There are no further questions. So I am thankful to Engineer Bhavan Rao for this excellent lecture and informative lecture. And the question answer session at the end, I am thankful to all the participants. So now I will end this session. Thank you, one and all.
Thank you.
Thank you, sir.